Hello everyone. Today I will be talking about the topic laws of motion. Let's begin by understanding the fundamental principles that explain how objects move and how forces affect their motion. There are three Newton's law of motion. First law, inertia. Second law, force and acceleration. Third law, action and reaction. Newton's first law is called the law of inertia. It states that objects remain at rest or continues moving at a constant velocity unless acted upon by an external force. See here, a bus moving and the people inside the bus are also moving along with it. When the bus stops suddenly, the passenger move forward because their bodies tend to keep moving. This demonstrates the concept of inertia, where an object resists any change in its state of motion. Newton's second law explains how force, mass, and acceleration are related. See here, an empty shopping cart moves easily and accelerates at faster rate when pushed. But a shopping cart filled with groceries has more mass. So with the same push, it accelerates less. This is why greater force increases acceleration while greater mass reduces acceleration. This relationship is expressed as force is equal to mass into acceleration. Newton's third law states that every action there is an equal and opposite reaction. See here, during a rocket launch, a rocket pushes the hot gases downward with great force. In reaction, the gases push the rocket upward with equal and opposite force, causing it to lift into the sky. This is the perfect example of Newton's third law of inaction. To summarize, the first law explains the inertia. The second law explains how force affects acceleration. And third law describes action and reaction forces. Momentum is the quantity of motion an object has. It depends on both of its mass and its velocity. See here, the truck and the car are moving at the same speed, but the truck has much greater mass. As a result, the truck has greater momentum than the car. The greater the mass or speed of an object, the greater the momentum. The law of conservation of momentum states that in an isolated system, the total momentum before a collision is equal to the total momentum after the collision. See here, the girl throws a ball and it collides with the second ball. After the collision, the second ball moves forward because momentum is transferred from the first ball to the second. This shows that the total momentum is conserved. Impulse is the product of force and the time for which the force acts. It changes the momentum of an object. See here, when the ball hits the hard wall, the impact time is very short because the wall is rigid. So the ball reverses direction quickly. But when the ball hits soft cushion, it takes a longer time to reverse, which reduces the impact force. This is the same principle used in seat belts and the airbags, which increases the stopping time to reduce the force during collision. Friction is the force that opposes motion between two surfaces in contact. See here, the worker pushes the box along the conveyor belt, but friction acts in the opposite direction, resisting the motion. Without friction, everyday activities like walking, writing, and driving would not be possible. There are four main types of friction: static friction, sliding friction, rolling friction, and fluid friction. Each type acts under different conditions and affects the motion differently. Friction opposes the motion, making the box harder to push. Friction between the tire and the road provides a grip for safe driving. Static friction keeps the book from sliding. Air resistance is the type of friction that slows the skydiver as they fall. Static friction prevents an object from start moving. Once the object begins moving, static friction is replaced by kinetic or sliding friction, which opposes the motion as the object slides across the surface. Friction has both advantages and disadvantages. It helps us walk, ride, and stop vehicles safely. However, it also produces heat, causes wear and tear of surfaces, and leads to energy loss. Circular motion is the motion of an object along the circular path. See here, the object keeps moving in a circle because the centripetal force acts towards the center. In this lesson, we will learn the basics of circular motion. In our upcoming videos, we will explore this topic in greater detail. Roads are banked on the curves to help vehicles turn safely. The inclined road provides additional centripetal force, reducing the risk of skidding and improves stability. A free body diagram or FBD shows all the forces acting on an object. In this example, the weight acts downward, the normal force acts upward, the applied force pushes the block to the right, and the friction acts to the left opposing the motion. The common forces shown in the free body diagram are weight, normal force, friction, tension, and applied force. Identifying these forces helps us analyze motion using Newton's law. To conclude, we learned Newton's law of motion, momentum and impulse, friction, circular motion, and free body diagrams. These concepts helps us to understand how forces act and the motion objective in everyday life.